Alright class, we're going to begin with the product rule for exponents now. And we have two bases that are the same, and when they're the same and you're multiplying them, you go ahead and add the exponents. Here in the formula you see a to the m power times a to the n power, and you just add the m and the n. So here we have 3 to the 4th power times 3 to the 7th power, and what you do is you leave the base of 3 and you just go ahead and add the exponents of 4 and 7, and that gives you 3 to the 11th power. And that is actually your answer. You could figure out what 3 to the 11th is on your calculator, but it would be really big. So we'll just leave it as 3 to the 11th. So here we've got 5 to the 3rd times 5, and the tricky thing on this type of problem is many of us forget that there's really a 1 there that's invisible because there is 1 5 there. And so what we do is we would just take 5 to the 3rd and add it with the 1, and you would get an answer of 5 to the 4th. Now, let me show you why this rule is actually working for these problems. It works better with the smaller one, this 5 to the 3rd. And so what's happening here is 5 to the 3rd, 5 to the 3rd, is really 5 times 5 times 5. And then if we're timesing it by another 5 to the 1st power, all it means is you're adding another 5 in there. So that means that there's 4 5s, and that's what 5 to the 4th is. So that's really what's happening here, and that's why we're adding the exponents. Okay, now let's look at this last problem on the bottom. And what we see is that there's a few bases, and what I want to do is put the numbers together, the 5 and the negative 3, and I'll just multiply to get 5 times negative 3, and then I'll put the y's together. So y to the 2nd power times y to the 4th power. And you deal with the numbers and the letters respectively. So I take the 5 times negative 3, and that gives me negative 15. And then I take my y times y to the, or y to the 2nd times y to the 4th, and it just gives me y to the 2 plus 4. So the answer will be negative 15 y to the 6th power. Okay? So let's continue with some more product rule for exponents with some variables here. We've got two different ones. We've got an x to the 2nd and a y to the 4th. The reason why I have this example is to show you that there's nothing that you can do. The answer is still just x to the 2nd, y to the 4th. This only works if they were both x's or both y's. Since they're not, you leave them next to each other. There's nothing you can do. Down in this next problem, they're all y's. They're all the same base. So I get to write y to the 3 plus 8 plus 2. And so that gives me y to the 13th power. And then this last one is very similar to the last one on the last page, where I need to deal with the numbers and letters separately. So I put the 7 times the 2 together, and then I'll put the two p's together, so p to the 3rd times p to the 5th, and then I'll put the two q's together, so times q to the, there isn't anything there, so it's a 1, so I put q to the 1, and then q to the 2nd. And so you go ahead and multiply the 7 times the 2, and so, okay, I did a little erasing there, so 7 times the 2 gives me 14, and then p to the 3 plus 5, so I add those to get 8, and then times q to the 1 plus 2, which is q to the 3rd. And that's your answer for this third problem. So the bottom line for the rule for product rule for exponents is if it's the same base with different exponents, you add the exponents. So now let's go ahead and talk about the zero exponent rule. Now the rule is up here in the top right hand corner. Anything to the 0 power is 1, except for 0. But any other number to the 0 power is 1. So I have 6 to the 0 power. The answer is 1. So it's pretty basic, but then it gets more complicated. Like on the second problem, see how there's a negative sign out in front? This isn't negative 6 to the 0 power like the third problem. This is negative times 6 to the 0 power is really what this problem is. So 6 to the 0 power we already decided is 1, but then I have a negative sign on the outside, so it's negative 1 as my answer. Contrast that with the second problem, or this third problem here, where I have the negative 6 inside the parentheses, and I'm raising it to the 0 power, so the answer here is actually a positive 1. So notice the difference between these two problems. It is a big difference, the difference between getting it right and wrong. Now the third problem you can see, the negative 6 to the 0 power, that's 1. Then there's a negative sign on the outside. So the answer here will be negative times the 1. So the answer is negative 1. The negative came from the outside and is sitting in there, whereas the 1 came from the inside the parentheses. So here's some more zero exponent problems. So we have to do the exponent part and then a little bit of arithmetic after that. So first thing I got to check out is that 5 to the 0 is 1, and then I'm going to be adding 12 to the 0. Well, that's also 1. So I'm really just doing 1 plus 1. The answer is 2. Okay. Now, even if there is a variable in the problem, like this 8x to the 0 power, even the variable still turns into a 1. So this whole thing just turns into 1. Now, notice the bottom little subscript there. It says x can't equal 0. That's because 0 to the 0 power is undefined. So what we're saying is that this x right here can't be 0, otherwise this whole answer would be undefined. So for everything else, though, any other number other than it being a 0, the answer would be 1. Because it doesn't matter if it was 8 times 20, 8 times 15, anything, whatever that final answer would be, you raise it to the 0 power, the answer is 1. Now the same thing holds true with this x to the 0 power. There should actually be an x can't equal 0 subscript, but x to the 0 power, that's 1. So what you're really looking at here is 8 times 1. The answer would be 8. So you'll see some problems in your homework where you're simplifying using a 0 exponent, and you've got to do that part first and then do whatever other arithmetic follows.